Thank you. So welcome everybody to this first elevator pitch this morning. My name is Carmen. I work in the southwest of Germany in Karlsruhe Institute of Technology, and I'm the coordinator of this project on hardwood joints. But I'm only a representative, of course. We are 10. 4 of the partners are from research, and 6 of the partners are from industry. And we come from the 4 countries highlighted in green on the right-hand side of the slide. Well, I wouldn't need to frame our topic anymore, but what we want to do is to bring, let's say, the forest into buildings. So it's an engineering project. We want to build with timber. With what timber do we want to build? We want to build with hardwoods. There are several reasons for this. Some of them are, for instance, that the hardwood stock in European forest is growing. That's what forestry people are telling us. But there is also a very strong engineering reason for doing so, which is that generally the strength of the hardwood species is much higher than the strength of the softwood species. So there lies a lot of potential in using hardwood species in timber engineering. Hardwood products are available today. They are still already used in building. Here are some examples. So you have beech glued laminated timber. You have beech laminated veneer lumber that's on the market. You can buy it and build with it. There are other species as well, for instance, birch. So you get cross-laminated timber panels, load-bearing cross-laminated timber panels made of birch. And you got birch glue as well. So what's the point of hardwood joint? Well, if you look at this photo here, you can see that if you want to build with timber, you need to join your members as well. So you have columns and beams, whatever, and you need to make joints and connections. So there we have another issue, and that is that the capacity of these structural members in general is much higher than the capacity of the joints. So this is one of the issues we're tackling. What we want to do is to increase this joint capacity to get a little bit, to close the gap between the member and the joint capacity a little bit. So that's our purpose, let's say. We want to foster such high performance hardwood buildings by developing the fitting joint technology and the design of these joints as well. How do we want to do this? Well, that's very easy. So we want to understand, of course, we want to complete the knowledge, we want to optimize our joints, that's what you've seen, and we want to implement everything. How do we want to do this? Here, just some very roughly. So the first thing we want to do is we need to understand all the different load-carrying contributions, the contributions to the load-carrying capacity of the joints. There are still some things we don't understand. We want to complete our knowledge. There are quite some knowledge gaps. For instance, in hardwood joints, you can observe failure modes timber engineers do not know up to now, which is that the fasteners themselves can fail. We don't observe this in softwood joints. The reason is that the density is much higher of the hardwood joints. That's something that we need to know in order to build reliably with these products. We want to optimize, of course, because we want to close this gap between the member and the joint capacity. And now, just some idea, all of you know this, right? That's a grater. You use it in the kitchen, and you know that you have to be very careful if the cheese piece gets very small, because you easily hurt yourself. So it has a very rough surface. And this very rough surface could be used as well in joints. Here, just some illustration. If you imagine a steel plate with a smooth surface being replaced with a steel plate with a rough surface, and then you pull on this, I think it's very easy to understand, without being an engineer, that the stiffness and the capacity of such a connection will increase. And a rough surface can be done not only with steel, what's easy to do, but you can do it on timber surfaces as well. Here's a product where you see this, well, I see it very well, but you have these little pyramids inserted in the surface to have a rough timber product surface, and then if you join these things with a fastener, you get a very increased friction. We want to optimize also in terms of modeling. Obviously, you always need numerical modeling as well if you deal with timber engineering, because otherwise you cannot carry out all the parameter studies. Many mechanical mechanisms can't be understood without finite element modeling. And what we use mainly is so-called non-linear beam on foundation models. And at the end, to close everything, of course, we would like to end up with a design manual for hardwood structures so that at the end, practitioners can actually start designing these hardwood buildings. Thank you. That was my pitch talk.